this any better? All right. Is that better? Okay. Classic turn it on and turn it back off again. Don't you just love technology? I love technology. Awesome. All right. Sorry about that, guys. It was probably because I did unplug my thing. I'm running between two computers now, so everything got like unplugged and replugged back in, and probably should have known better and just restarted it. You know, when I did that, I was playing some Kerbal Space Program 2 today, which was super fun. I spent like 6 hours on our Patreon and supporter live stream. It was awesome. I actually made it to Eve and landed on Eve and got back off of Eve properly without any like cheats or anything, and it was really fun, really hard in KSP2. So yeah. So yeah, let's go through and do what we do here when we're waiting for a rocket launch, and that is go through a little website called everydayastronaut.com. This is this is under upcoming launches. You can read our pre-launch previews. So this is for Good Luck, Have Fun, the first inaugural launch of Terran 1. So this is planned. This did change now, of course. I forgot to refresh it. But it seems like the current T0 time, as far as I'm concerned, is less than... our time's showing 1 minute and 7 seconds, but I think... it's basically 40 minutes from now, though, if I remember. We'll try to fix. Can we just hide the T0? Let's see. Okay. The mission name for this is Good Luck, Have Fun. Awesome nod to video game culture. The rocket launch provider who is actually launching this rocket is Relativity Space. The customer who is paying for this is Relativity Space because there is no customer on board. It is just a demonstration mission. The rocket is the Terran 1. The launch complex is Launch Complex 16 out of Cape Canaveral Space Force Station. The payload mass, there is no payload on this test launch vehicle except for a 3D printed metal ring that weighs only like 1.5 kilograms, so 3.3 pounds. It was their first test print ever from their massive 3D printer. So that is cool, but they're really not trying to do anything with it. Sounds like they might actually be live. I'm going to try and make sure I'm tuned in here. Okay, no, they are not. Okay, just making sure. So this is going into a 200 by 210 kilometer low Earth orbit at 28.5 degree inclination. Means that they're going to fly due east out of Kennedy Space Center, or Cape Canaveral technically. And that is a low orbit, so it will deorbit itself relatively quickly. Will they be attempting to recover the first stage? No, this is not a capability of Terran 1. It probably will not be a capability of Terran 1, but Terran R will be fully reusable. That is the vehicle they're already working pretty seriously on. Where will they attempt to land the first stage? It'll crash into the ocean because it's not being landed. Will they attempt to recover the fairings? No. And are these fairings new? I don't even know if I'd call them fairings. My understanding is it's just a nose cone for now. They're not demonstrating even a deployable payload on this mission, is my understanding. I might be wrong on that. The weather is currently 90% go, but that was as of 2 days ago. They have been dealing with some upper level winds. That was the concern why the launch got scrubbed back a little bit. We still have not... we still have not heard from them. People are saying that they are alive. Let me make sure I actually have them. It still says waiting. Maybe we need it. Oh, there we go. Okay, so I've got them over here. I'll bring them up when it's relevant here, as soon as I start hearing stuff. Meanwhile, let's finish up our pre-launch preview. So, first mission for Relativity. The first launch from Slick 16, or technically, I don't know. There's a debate here because Slick normally denotes anything down in Cape Canaveral for some reason, in Cape Canaveral Space Force Base, anything up in Kennedy Space Center nearby, same portion of land basically. Those are normally just Launch Complex, and anything in the Cape is typically Slick. Relativity has been saying only... Slick, so that's been just honestly a bit confusing. So yeah, who really knows at this point? I obviously don't know, but we'll see if they tell us more about that. This is the third launch attempt of Terran 1, the first launch attempt of Terran 1, the first launch of Terran 1, hopefully. The first launch of a 3D printed rocket, 85% by mass 3D printed, absolutely incredible. 43rd orbital launch attempt of 2023. So we've got a little rundown here on the rocket, the payload here. That's what the payload looks like, just this little puck thing. That's pretty cool. What we're going to be looking for at starting at T-minus 7 minutes. Or no, T-minus 7 hours. Sorry. And then, the webcast they're starting, but I think they're starting, we'll see here just in a second what we're actually at for the webcast and the actual T0 time. It did change, and I don't know where we're at with, I think our T0 time is about right. I don't know if you can really see it too well right now, but yeah. So if you guys want to learn more about what Terran 1 is, how this incredible vehicle has been 3D printed, and about their Aeon 1 engines, all of the fun stuff here is the Terran 1 on the left and the Terran R they're going to be working on and already working on the right. Very, very cool. This article is written by Flo, so everyone say thank you to Flo in chat. It's so awesome to have our website crew making such awesome content, keeping us in the know. All right, so we've got this pulled up here. I'll just kind of get it in the background. And, yeah, let's see here. I'll get going to some questions. So, let's see. Musical Wolves, how are you, Musical Wolves? What will happen to the first stage? Will it be the first stage? Will it be set to deorbit after it completes one orbit? So the first stage will just splash down in the ocean because it is suborbital. It's not reaching orbital velocities. It'll, first stage is just barely make it into space with about a third to a quarter of the amount of orbital velocity, and then it's the upper stage's job to do the rest of the work normally. This first stage is just crashing down. The second stage will, I believe, deorbit relatively quickly. I'm not sure what their exact mission plan is there, though. They haven't really said specifically. All right. Let's get back on the right foot. Mike, I apologize for the rough intro. I love how that always happens. Oh, this is awesome. Mitch at the press site. Awesome. Enjoy the launch. I really hope you get to see. I mean, it's going to be pretty cool that, a night launch of a methane rocket will be bright blue flames. It's going to look absolutely amazing. Thank you so much to Red. And this is also from Mans on Mars. How does the Terran R compare to Neutron from a commercial and performance perspective? Realize they aren't built. I think they're quite similar. If I remember, I don't remember the exact details on Terran R, but I believe it's around that same class of vehicle. Like, medium lift launch, medium to heavy lift, if I remember, is what they're actually touting. But I for some reason, I feel like it's Falcon 9 class, but the idea is that it's going to be fully reusable. So, hey, look at that. We have a rocket on the pad, and we have a T0 time. Ours is close. Yep, 28 minutes and 23 seconds. So we'll get that lined up here in just a second. And as a matter of fact, I am going to actually lower this down just a little bit here. Let's listen in.
Welcome back to round 3. Thank you for joining us again from Cape Canaveral Space Force Station in Florida, where we are ready to launch Terran 1, the world's first 3D printed rocket. Today's flight is named Good Luck, Have Fun, or GLHF for short, and this is Relativity's first launch. We'll be bringing you live coverage from Launch Complex 16, which is our launch pad at Cape Canaveral, as we prepare for historic liftoff. I am Rachelle Aniceto, the Chief of Staff for the Vehicle Architecture and Technology team at Relativity Space. I support our Chief Architect, Kevin Wu, in the design, development, and product management of our medium to heavy lift reusable launch vehicle, Terran R.
And I'm Arwa, Program Manager for Test and Launch at Relativity Space. I'm responsible for supporting the teams that design, build, and operate our test and launch sites across the country for both our Terran 1 and Terran R vehicles, including operations on the stages, engines, and propulsion components. Together, we'll be guiding you through our third launch attempt today. Now, if you joined us on March 11th during our second attempt, you know we came very close to launching with 2 aborts during terminal count. Here's a quick breakdown of the reasons for those aborts. During the first abort, we experienced an issue with the stage separation automation system a few seconds before T0 that properly aborted at T-minus 0.5 seconds. Then the team pushed an update to the vehicle automation system, successfully recycled the vehicle, and secured a new T0 time, which was during the last minute of our launch window. After recycling at T-minus 45 seconds, we had an automated abort on the second stage fuel pressure, which was only 1 psi outside of the limit. Let's hear more about our previous attempts from our chief engineer, James Harris.
Of course, now their T clock disappears. So of course, we're probably going to get a copyright strike for that. I always forget. YouTube's so finicky about this. Let's answer a few more of you guys' questions. Those of you that have watched this have already seen these from the previous attempts. Speaking of music, from Bob Edwards, thanks for all the space stuff. Also love the music. What program to use? I am a Logic Pro guy. I've used Pro Tools in the past, but Logic has been what I've been using for about the last 10 years or so. It's just been very easy to work with, and I enjoy all the options that it has. Any Dear Moon updates coming down the pipeline? Honestly, nothing yet, really. We're kind of just waiting for that first orbital launch. That will set, the orbital launch attempt and the first orbital launch of Super Heavy, of Starship Super Heavy, will really put a lot of things into motion. So, yeah, a lot of stuff is hinging on that. And then from there, a lot of things will kind of get aligned. And so we're all waiting on that, and it's going to be really exciting. As you guys know, we're hopefully within about a month or so of that first launch attempt. So I can't wait for it. Hopefully you guys are ready too. Third time's the charm. Let's hope it works. Thank you so much from Alex. Awesome. 18 months of membership from VLF Transit. Thank you so much for the support. I really appreciate that. Hopefully you and others caught, again, I did a Patreon / YouTube member live stream today for 6 hours. So if you ever are missing what we're doing here at Everyday Astronaut, consider becoming a member or a Patreon supporter. As little as $1 a month gets you into some of these extra live streams that we do and just kind of some of the fun behind the scenes things too. So it always means the world to me. It's just such an honor so that I get to do this kind of stuff for a living, talk about rocket science, and I've been scripting 2 videos right now, and I think you guys will really like them. All right, they are currently in a hold. All right, give me 1 second here.
5 minutes. Our launch time right now is delayed due to 2 reasons. So we had the upper level wind shear being outside of stage 1 gimbal limits. However, the latest balloon data did show that it is now within acceptable limits, so we'll be keeping a close eye on that, and we'll hold the clock as necessary if needed closer to launch. However, now there is currently a boat in the range, so we are holding the clock and waiting for the range to clear that boat out of the hazard zone. We'll keep a close eye on it and give you an update shortly here once we know what happened.
Oh my God. Wayward boats. I don't know. This is the second time they've had a problem just launching this rocket with traffic. The Cape should be used to this by now. The Cape has so many rockets flying so often. I mean, Falcon 9 launches out of there every 3 days. How is the marine traffic not prepared for this by now? Maybe they're not used to this. Might have a little bit bigger exclusion zone because it is a new rocket. Anyone in our Discord familiar with the maybe if let's see, Alex or somebody, I don't know who's in there that might have the NOTAMs, but I would be curious if I would imagine that this might actually have a bigger NOTAM than a Falcon 9 launch, a bigger exclusion zone than a standard Falcon 9 rocket launch. Since this is this is the first time this rocket's flying, there will be extra considerations, extra caution for that. But let's go ahead and talk about this rocket here. I feel like it's something that if you tuned into the other ones, a lot of this will be will be repeat. And don't forget, you can ask questions. Our mods will try to pull them into chat here assuming we have some mods for this. I don't know who's all available tonight to help out, but we will bring some of your just chats, and you don't have to do super chats or anything. Just ask a good question, and we'll try and queue those up here. But yeah, it's Ban says it's me in the boat, Tim. Ban, if it's you in the boat, you're about to get a lot of angry rocket nerds. Naughty from Ban. So, okay, let's see. The crazy thing to think about this with this rocket, of course, is that it is completely, or 85% 3D printed. So the actual tanks are 3D printed, which is pretty wild. Let's see here. Yeah, I don't know what's with our overlay right now. Our overlay is going crazy. Sorry about that, guys. I'm just going to go ahead and hide that for now until we get that sorted out. Sorry about that, guys. Yeah, it's pretty impressive that they are able to 3D print a structure this much, and to be able to, you know, test that out, test it to the limits. Obviously, there's not much more dynamic than a rocket launch to test the heat, the cold, the aerodynamic stresses, I mean, everything. It's good. They're going to put their 3D printing technology through their paces. And what's great about that is that will allow them to figure out, you know, what's going to work for them in the future with their next rockets as they continue to develop the, you know, the Terran R. Oh, they are holding at T-minus 25 minutes due to the wayward boat. They are holding until the range clears it. Okay, so what's trying to get on to some of you guys' questions here. So this is a question that I personally have for myself. This is from Ethan. I hope that showed up. Oh crap, it didn't show up because I messed it up. From Ethan, hang on. Let's see if I can fix this real quick. My bad, guys. Sorry. Okay, from Ethan. Basically asking here if they'll ever use traditional methods of production after it gets into rapid production. I really assume that at some point, you know, once they've kind of proven the technology, see what's best and see what's, you know, not great. I've always thought building a tank can't be that hard. You know, it's basically more or less you're welding a sheet together into a tube, a cylinder. It's not that difficult, but then you have to add things like baffles to make sure the liquid doesn't slosh about. You have to add things like the raceway for electronics and all these other bits. And maybe as far as just pure cost and production effort, maybe it is cheaper and better to just 3D print the thing. It does add mass, and mass is not a friend for rocket scientists. But I wouldn't be surprised if there is a trade, an ongoing trade that they're going to kind of go back and forth. See how this does. Tonight they're going to, you know, when they finally get this thing off the ground, it'll be an all-up test of all their systems. From there, they can really figure out, you know, what does work and what does not work. You know, that's going to be... Yeah, then from there they can make design decisions based on, okay, how did that work? Was that actually worth it, and was it not? Okay, I'm gonna try to answer a few more guys' questions. What does the T-minus 25 minute hold mean? This is from, yeah, let me get this up here, from the Animist. So that means that the vehicle is currently kind of on standby. They were looking to try to launch in 25 minutes, but because a boat literally is like, you know, you're out there in Florida, the rocket's going to be flying east, so there's an exclusion zone of where boat and marine and air traffic cannot be, and anyone, period. There's like no human and property can really be inside that exclusion zone. So the rocket was kind of getting ready, going down its T clock and getting closer to T-minus 0 when it would lift off. And the range, the people that literally are sitting there with like binoculars and radar and all these things to be able to try to figure out where traffic is to make sure all the public is safe. Notice that there was a boat inside the exclusion zone. So now they put the rocket on hold. The rocket is just kind of in this recycle position, waiting to hopefully still go for launch. But meanwhile, they do have to clear that boat. Half the times it can just be a radio call and say, hey, get out of here. Sometimes you have to send like a helicopter out. It all just depends on the status of the boat. A boat could have always, a boat can die, and the engine can malfunction or whatever, and it can get stuck. So they have to tow it then, all these other considerations. So a boat in the range is not great. I'm sure that they're hoping that it does get cleared up here rather shortly. Let's see. Let's see. What launch am I most excited for this year? I think that's probably, I feel like that's pretty obviously Starship. It's going to be, how can you beat the world's biggest, most powerful rocket ever? That's absolutely bonkers to think about. I mean, that is actually what we're going to be seeing hopefully here in the next, I would say 4 to 6 weeks. That's kind of my current estimate, 4 to 6 weeks. And by the way, that I don't have any inside information. I know, yes, I'm going to be a passenger on Starship, but I don't have any crazy fun information for you guys. My best guess is 4 to 6 weeks. So just keep that in mind. Yeah, that's what I'm most excited for. There's a lot of cool rockets. Another one, obviously, I'm excited about Relativity. That's why I'm trying so hard to be able to stream this one. Made it a priority to be able to stream it. I was not able to stream the last attempt was that a week ago Saturday? I was at South by Southwest. I was on a panel with Jack Beyer and Ryan Chelinsky and Jenny Houtman. I never remember how to actually say her last name, but yeah, it was really fun. We had a great time. I was literally sitting there on this panel watching the live stream, and then I breathed a sigh of relief when it scrubbed, because I was like, oh, okay, now I can just focus and not worry about this rocket launch. Yeah. Zachary says, oh, they say there.
5 minutes for a boat in the hazard zone that we're waiting for the range to clear. While you're waiting here, I know that you see a big ball of fire next to our vehicle. I just wanted to tell you all that not to worry, that is on purpose. That's just our flare stack, and it's used to vent flammable gases from prop loading and venting operations and priming of the engine igniters. We're going to continue to hold until we have that update from the range.
So who watched my how to start a rocket engine video? I hope a handful of you. Say I watched it in the chat if you watched my video about how to start a rocket engine. It is an hour long. I know it's quite the commitment, but we dive really deep in everything. I hope those of you that watched it remember why there is a fireball, why there's a flare stack for methane and hydrogen rockets. For those of you that didn't watch it yet, the reason is, let's see here. Oh, cool. I love it. I love it. So many of you guys watching. Thank you. Amazing. Good. The reason is just a quick little overview of why it does have that flare stack there, is because as methane boils off, so when oxygen boils off from a liquid back into a gas, it expands about 1,000 times, and it's okay to just vent that out. That's actually what we're seeing right now on screen. You're seeing vented gaseous oxygen. We're seeing oxygen that boiled off and is being vented out because it expands 1,000 times. You can't keep that inside the same container as liquid oxygen. It needs to be vented out so it doesn't rupture the tanks. And it's still really cold, so you're seeing it come in contact with the atmosphere. Now, methane does the same thing. Methane's almost exactly as cold as liquid oxygen, liquid methane is. And it will do the same thing. As it warms up, it boils off. But instead of boiling it off and just letting it vent out into the atmosphere all willy-nilly, they basically have to repipe it and send it out to a flare stack. And that's what that flare stack, that ball of fire is. That's there just to make a controlled release and controlled flame out of the methane. So otherwise, you could accidentally have a buildup of methane and potentially a detonation of methane, because obviously it can combust with the oxygen in the atmosphere. So you don't want just a bunch of unmitigated and uncontrolled methane, gaseous methane, just spewing into the atmosphere. That's bad. So they burn it off to make sure it doesn't do anything. And also when they start to chill the engines down, as they begin to load the engines for chill down, they will put some liquid methane into the pumps. And then there's another opportunity where you're going to see a lot of boil off, because with this particular rocket, there are 9 engines. They're going to fill up to the main fuel valves liquid hydrogen or liquid methane in order to get the temperature down to a point where the engines can handle all of that cold temperature. Yeah. Thank you to all of you again who watched that video. It really, really means a lot. I did see someone ask, and I missed it now, so I'm sorry that I missed it. But somebody did ask, what is the why are so many launch vehicles nowadays using like 7 or 9? You know, some of these small launch vehicles and even big ones are using 7 or 9 rocket engines instead of, you know, like 1. For instance, like the Delta IV. Also, SpaceX's Falcon 1 had just 1 engine. Why aren't people doing 1 engine? Well, there's a few things to factor in here. Number one is SpaceX kind of proved that if you make many smaller engines, it's a lot cheaper than 1 big engine. You obviously have tooling and a lot of things, even just physically how you install and maintain these engines and fix a problem. If they're small enough to be able to kind of be handled by a person and a forklift or something, that's great. If they're huge like the F1 and taking one out, or even the RS-25 is massive, that's a big job. They're just trying to make it. You see how quickly they swap out Raptors on the Super Heavy booster. There's 33 Raptor engines on the current iteration of Starship Super Heavy. And it's so easy for them to be able to swap out engines because they're relatively small. They mass produce the huge number of these engines. It brings down the cost. It makes it so they have a lot of expertise and data on this engine type. It means they get a lot of runtime on them. They learn a lot of problems with them. They get all the kinks worked out because there's a much larger set of engines. Let's say they decided to do it Saturn V style and make 5 of the world's biggest engines. That's what, 1/7, 1/6, 1.65 or whatever, 6.5 times more engines by having 33 smaller Raptor engines. So smaller companies, it's new launch vehicle companies, Rocket Lab, things like that. They have also come to the same conclusion that, hey, we can make 7 or 9 smaller engines better, cheaper, faster than we could 1 large engine, 1 or 2 large engines. Now, that is to say, what was the other part of that? Oh, yeah, the other fun thing, too, is there's a little bit of a bell curve or a bathtub curve of it is likely more reliable to have multiple engines. You can have engine out capability. Of course, if you have an engine go out, you could potentially run into other issues like, blowing up other engines nearby. But most days, these days, there's so many sensors. The rockets are so smart. They can sense an engine going out before it, becomes catastrophic, and they can shut it down safely most of the time. We've seen SpaceX. I think they've had 3, maybe was it 4 Merlin engine shutdowns, and none of them have ever led to a loss in mission, even, let alone a loss in rocket. So, they've never. It's just proven to be incredibly reliable. Of course, if you went to the other end of that, you could have so many engines in there that it's more prone to failure. But there's definitely some kind of sweet spot. I think we're going to see that, with Starship having just a huge number of engines. There will be some teething pains until they really get that system to be extremely reliable. But it has the potential to be incredibly reliable. All right, let's see here. Let's see. I'm not sure. Tactile Turn is a deep space pen about to be out of season. It's right up your alley. Lovely content. Well, thank you so much, Gator. I'm not even familiar with Tactile Turn. Is that a pen company? All right, I'll check it out. Christopher Eric, thank you so much for becoming a member. And same with Gator Aaron. I appreciate your tip and the membership. You guys, you actually, it's funny, now that you are members, you can go back and watch the stream that we did earlier. It was a ton of fun. I'm thinking about it right now. I still have Kerbal pulled up on the gaming PC, and I'm sitting here thinking, man, I would love to get back to playing that. I had such a good time. So if you, let's see, Deer Range Violator Boater seems pretty clear to me. Yeah, it's a big exclusion zone though. So thank you to those of you that have recently become members. Again, feel free to check that out and stay tuned for some other future live streams. 5 months of memberships from Christopher Johnson. Who makes your t-shirts? Do they have any new designs coming out? I really love the engine diagrams. I ran into Mike Massimino. He loves the RS-25. Very cool, Christopher. Well, my girlfriend Allie does the designs of our t-shirts. She has a graphic design company called Gravity Coast. Amazing work. We just released a new shirt here recently. We released a brand new full flow stage combustion cycle shirt that I'm absolutely in love with. It's rarely left my body since it came out. It's super soft and I love it. But these are all produced in California, in Long Beach. Actually, my friend owns a production and distribution shop company. And so he does all of our merch. His name's Andrew. He's awesome. Yeah. So that's who does our merch and where it comes from and how it works and all of that stuff. Yeah, I'm very proud of it. It's a lot of, it actually is a lot of work because we don't do print on demand. We do runs of shirts to try to make them higher quality. You know, that's why there's custom tags all over the place and the hem tag and all that stuff, and why they, you know, feel good and last a long time because we actually properly manufacture them instead of doing print on demand stuff. So it's a lot more work, but I always believe in high quality products. I don't want my name. You guys know, how obsessed I am with quality with my videos and how much effort we put into the videos. Same thing is true of the shop. We just really, really, really want to make the highest quality products, you know. And of course, you guys have seen, for the millionth time, you've seen our Falcon 9 model rockets as well. Very, very, very proud of these. They're metal, as you know, and very highly detailed. I love that they're, you know, you can actually collapse the legs and do all this fun stuff with them. These we still do have a few of these left before they go out of stock. I think we do have another shipment coming, but if you guys do want to support what I do and get, I know this is the highest quality, highest detailed Falcon 9 model rocket that you can buy, period, that you can get your hands on. And it's actually durable. Ooh.
New time in the next 5 minutes, so we are currently standing by.
Ooh. Standing by for new T0 time. That's great news. Standing by for new T0. I love it. That's what we want. Okay, we don't need my big dumb face anymore. Okay, so hopefully in the next 5 minutes we'll learn. Yeah. Hopefully in the next 5 minutes we will learn what's going to go on there. Dustin, took my family to KSC a few days ago. Was able to explain so many things to them thanks to your rocket engine videos. Seriously, made the experience much more interesting for them and more fun for me. Amazing, Dustin. Thank you so much for saying that. Greatly, greatly appreciated. And that's the whole point. I think people forget, like for me, when I go visit a historic place or something, if I just walk through, I'm like, oh, cool, cool, cool. But you know what makes it a lot more exciting and what makes me really appreciate a historic place is having someone walk me through and tell me awesome stories and explain things. I mean, I might be, you know, that might be like the 75-year-old in me that just loves that kind of stuff. But, you know, if someone's telling, that's just the whole point, is like you get excited to learn things. I think we kind of all crave that to a certain degree, and it just makes an experience a lot more fun. Same thing is true with rockets and rocket science. I truly believe the best way to get excited about rocket science and space flight is just simply to learn. I really think the more you learn, the more you understand, the more exciting it is to watch, the more exciting it is, the better appreciation we have for what the engineers are doing, the work being done, what the scientists do kind of day to day. At least gives us some sense of appreciation for their hard work. But it makes it more fun when you go to a museum. So actually, I have a video that we're going to be releasing probably here in the next week or two. It's actually just me walking through the S-Tech Museum in Amsterdam. And I walked up. They had two engines that I know nothing about. They had oh God, what's it called now? Well, the engines on the Viking 1.
Coordinated a new T0 time and are currently targeting 03:05:00. The clock will resume in approximately 5 minutes.
03:05. So is that? That's 10:05. So 30 minutes.
We are targeting a new T0 time that we have now confirmed with the range at 23:05. Again, that's 23:05 Eastern. The clock will resume shortly according to that launch time.
There we go. There we go. Okay, we did have this thing that I wanted to share real quick. It's a picture of the exclusion zone. I just figure we could share this with you guys. So Emery Kelly from Florida Today. Is that who Emery's with? I forget. Anyway, there's a boat in the blue. So this is the exclusion zone. There's a whole large red, exclusion zone. No humans can be within that red zone. The blue zone, going on, blah, blah, blah. But this blue zone is apparently where that boat was. Very naughty. Yeah. It's too bad. All right, we'll keep that back up there. So anyway, back to the... which engine was it that I saw? I saw the Viking 1. This is what I liked about it, is I know nothing about it. Rocket. No, not Viking 1. Vikram. What's that called? Ariane Space. Ariane 1. Ariane 1. What's this engine, though? I thought it was the Viking engine. Ariane 1. Oh, 4 Viking 5 engines. Okay. So what was fun is they had these engines there, and basically the whole thrust section of an Ariane 1. And I just sat there and just dissected what I could pick up from scratch, just from just observing it. It was really fun. It had, an ablatively cooled throat. It had, you could see film cooling, and it's a really unique injector pattern. Really unique injector that's like annular around the outside of the combustion chamber, not sitting on the top of the combustion chamber. Really unique. I figured out just by looking at it that's hypergolic because there's no igniter. I did get thrown off by one thing. Apparently it has a water injection system for its gas generator, but it was really fun going through it and just doing a walkthrough. I had a really, really good time doing that. And then we also looked at the Ariane 5's rocket engine, why am I blanking on that too? This is not a good day for me. I already spoke way too much earlier today and my brain is fried. It uses the... What is this? Booster core stage uses the Vulcane engine. That's right, the Vulcane. So yeah, went through and just that one didn't have a cutaway, but we still kind of did some observations from the outside of the Vulcane, and it was just so fun just to like kind of take and try to dissect an engine from the outside and inside, and just figure out what you can learn about it. It was super fun. So yeah, stay tuned. That'll be just a fun, quick little random video that we'll be putting out here relatively soon. Oh, Zach, how's it going? Thank you for the chat. I really appreciate it. So no, our mod system is actually through this entirely separate program. And I don't know how to add and do all this stuff for people. It's a bit confusing, but it is what allows us to put stuff up on screen. So I will keep that in mind that we probably do need to get a couple extra people there. Let's see. This is from Red. Make a video on on rotating detonation engines. Yes, that is on the list. The list is very, very long. I literally have 4. I'm in the middle of 2 scripts right now. I started making one. It's really long. And then I realized, okay, I just have to cut this into 2 videos. There are similar topics. One will kind of be a primer for the other one. It's going to be one of those things where I'll leave it up to you guys to watch it in the right order. But I really do think that the knowledge in one is going to be necessary for the knowledge for the other one. So... but that one's going to be amazing. And then I have 2 or 3 other videos literally in the pipe. Some half scripted. I mean, there's a lot of stuff to do. I would love to see rotating detonation engines, especially maybe once they fly. Right now, there's already been a handful of videos about them. Scott Manley's made a video. I mean, I've seen a handful of people make videos about them. So, right now we'd just be regurgitating the same information that we already have. I would love to wait until there's some milestone. Maybe go visit one of these companies working on one and try to get a sense of how it actually works. Thank you so much for... we'll not put those names up on screen there, but thank you so much to Vital and also to William Green for becoming a member. William Green, maybe add 1/100 scale humans to future rockets. Do we have any mods in here that can do... That's 2 people to ask about that.
Clock is rolling. We are just under T-minus 25 minutes now. We did receive confirmation that propellant loading is complete for both stages. We're going to keep an eye out on those upper level winds and on the range today, but the vehicle is healthy. So as of now, we're proceeding with 2305.
Thank you, Arwa. Arwa will continue to provide regular status updates over the course of the countdown. In the top left of your screen, you can continue to find our countdown clock to follow along in our pre-launch operations.
And now a quick reminder about the purpose of Good Luck, Have Fun. This is a first launch, meaning that while we're aiming for Terran 1 to reach orbit, our primary focus is on gathering the data and learnings necessary to develop Terran R, our much larger, medium to heavy lift, reusable launch vehicle. The lessons learned from this mission will also enable us to improve our software-driven approach to manufacturing.
And as a reminder, today's launch includes many firsts. Terran 1 is the first 3D printed rocket, which is 85% 3D printed by mass. It's in a race to become the first Methalox-propelled rocket to achieve orbit. If orbit is achieved, Relativity will also become the first venture-backed space company to have successfully reached orbit on its first flight.
And it's worth noting that while Terran 1 will be capable of lifting 1,250 kilograms into low Earth orbit, or LEO, today's launch doesn't have a customer payload. We do, however, have a memento aboard, one that's quite unique to Relativity that we'll tell you more about later.
Liftoff is currently scheduled about 22 minutes from now. This estimation may change as we continue to work through our countdown, but we will keep you updated along the way. Today's launch window lasts for 3 hours, and this provides us more time to troubleshoot any issues that could arise. And if any unforeseen issues arise during the countdown, we can pause the launch sequence if necessary, as you've just seen.
The window for today's launch attempt opened up at 2200 Eastern Time. The pad was cleared of all personnel at T-minus 4 hours, followed by the start of propellant loading, which has since been completed. We're now topping off our tanks and conditioning our propellant to the proper temperatures ahead of launch. Now at approximately T-minus 20 to T-minus 15 minutes, the launch director will poll the launch teams to ensure that all subsystems, weather, and the range are go for terminal count. Terminal count will then begin at T-minus 70 seconds, and that's when the vehicle's internal flight computer will take control of the countdown. Now, while we wait for T0, let's talk about the process that got us here.
Good luck, have fun is the maiden launch of our 3D printed Terran 1 rocket. Terran 1 is an orbital class rocket, so reaching orbit would be the best possible outcome. But as you've heard us say before, we are truly looking for some important base hits here today. Notably, a key objective for today's flight is largely about proving our hypothesis that 3D printing is a viable way to manufacture a rocket and it can successfully withstand the pressures of flight. Through robust ground testing, we're confident that we have a real shot at proving just that. So the more data that we collect from this flight means that we'll have access to more insights, and this will give us the confidence that we're able to execute on Terran R and help us solve all the hard problems that come with building a medium to heavy lift reusable rocket. As a business, we're following a Pathfinder product development approach. So the Terran 1 that you see on the pad today has always been our Pathfinder. It was designed to be a development platform for Terran R, and it has served us exceedingly well to date in that capacity as we've progressed through printing and testing ahead of today's launch. Arwa, let's remind everyone what we would call a success for today's launch.
Absolutely. Again, safely clearing the pad, getting out over the ocean, and passing the point of maximum dynamic pressure, or max Q, would be a big milestone for today's launch. This is again because it's the point where the structural loads on the vehicle are the highest, making it one of the most challenging phases of flight. And this is the point in flight where we really want to prove much of what has already been proven on the ground. During acceptance testing, the vehicle withstood loads even beyond what we anticipate it will encounter during flight. So passing this milestone would effectively demonstrate that 3D printed rockets are structurally viable. And then if we make it even further to stage separation, we will have achieved a full first stage flight, and that'll be another big accomplishment for the team. From there, we'll attempt to light the second stage and get Terran 1 to orbit.
Stage 2 is targeting a 200 kilometer by 210 kilometer orbit, and this is not a traditional orbital target, but that is our target for today, given this is our first launch and not a customer mission. As a reminder, we do not have a customer payload on this flight since it's not a customer mission. So instead, we are celebrating how far we've come by mounting our first ever metal 3D print from the first generation Stargate printer inside of Terran 1's nose cone. Of course, it was a failed print since no one had done it before. Let's go ahead and take a look at this memento. So that piece that you're seeing there is about 6.5 inches in diameter and weighs about 3.3 pounds. That is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with the GLHF and our mitosis logo to commemorate this maiden launch. We would be excited to see this memento get to orbit. But to take a step back and set expectations, we want to note that we are unsure how much of the second stage flight we will be able to share with you live. While we do have cameras on board, we will be prioritizing vehicle telemetry sensor data for this launch in order to maximize our learnings, and as a result, the video connection could be spotty. In the event that we do lose video, we will do our best to keep you up to date as we receive telemetry and information live.
And once again, we have strict safety protocols in effect for today's flight and are, of course, closely coordinating with the FAA and Space Launch Delta 45. These protocols are standard for all launches and ensure that no one would be in harm's way if there were to be an anomaly. Now, from our very first failed print 7 years ago, it's taken a relentless focus on innovation and almost countless iterations to get to where we are today. The world's first 3D printed rocket on the launch pad here at Cape Canaveral. And like the first print, Terran 1 is the first step of many towards making humanity a multiplanetary species. Now, as a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Terran R, our larger medium to heavy lift reusable launch vehicle.
Up next in our countdown will be the go, no-go for launch, which is expected to occur in the next several minutes. Let's take in some views of Terran 1 under the lights of Launch Complex 16 while we wait to hear from Mission Control.
Perfect. Very exciting. They last time it seemed like the poll was it T-minus 14 minutes, 12 or 10? I don't quite remember, but it was coming up it'll be relatively shortly, and they did air the go no go poll, which is very exciting, and I love it. Lucas, thank you for becoming a member. Again, memberships really greatly appreciated. Can't wait to do more Kerbal streams and things like that. It's going to be very fun. We got a handful of good questions here, but first, Leon, thank you so much for the generous tip. I much appreciate it. And Cynic in Chief from Angry Astronaut, amazing. I love Jordan, and I just found out that recently that Jordan's moving to the UK. That'll be crazy. Hopefully, he's going to be there to cover some of the incredible launches that are going to be happening in the United Kingdom. There's going to be some cool stuff. So tell Jordan hi, and thank you, Cynic in Chief. Okay, this is the question I was excited to answer from Dash Riptide. Thank you again for chat, but this is a great question. Yes, they are working already on a fully reusable rocket, not just a reusable. So they're going to be upgrading the Terran 1 like we see here. Eventually, they're going to be putting one of the next, I believe, Aeon R rocket engines on it, just a single one instead of 9. It is 10 times more powerful than their Aeon 1, and they'll be flying, hopefully they'll be flying the Terran 1 and the Terran R side by side. But for now, the Terran 1 as it stands is literally just, getting their feet wet, more or less. It's an opportunity to test a lot of their technologies, just a demonstration of, all of the things. Even how do you run just a manifest? How do you run a launch sequence? How do you run a launch countdown? How do you get propellant management, all of these things that you learn, they're just learning at a relatively small scale for now. It's a pretty big, small launch vehicle, though. Over a metric ton to orbit. That is one of the larger small sat launchers today. So it's already pretty big, and their Terran R will be substantially larger than that and be able to fly fully reusable, which is, of course, truly the goal. Very, very, very fun. All right, this is from Christopher Eric. Howdy from Texas. Your channel is legit. Keep up the good work. It is appreciated. Don't let spammers win. Oh.
Standing by for the go no go polls from Mission Control. This should occur in the next several minutes.
Yep, cool. Still waiting on that go no go poll. Thank you so much, Christopher. That really means a lot. I love being able to make videos for you guys. It's an absolute dream job. And I have, like I said, I've had too many videos. The list only gets longer. It's never gotten to the point I'm like, oh no, what next? It's just obscenely long. So thank you so much for that, Christopher. I really appreciate it. Mr. Tim, any plan to put a 4K cam in the studio? This is 4K. Yeah, we've got this studio doesn't have really anything like what we have down in Texas. In Texas, we have only 4K plus studios and switching hardware and encoders. There is an insane amount of hardware there, and it's capable of running fully 4K live streams. For this, when I'm here, honestly, you know, they're only streaming in 1080. Most of these cameras are probably scaled up 720, so there's really no point in me having 4K here. So I don't really worry about it. That way the latency stays lower too. But even out at Starbase, we're going to be running our streams out there at Mars, based out on Luna. So Mars is the studio space, Luna is the production truck, and they're plugged into each other. That we're going to run in 1080 just mostly for lower latency and better reliability. We really care about having our streams not go down. The data out there is horrendous, so we're just doing the best job that we can to, just to make sure that's reliable and quick and snappy and get you guys the best coverage we possibly can. And hopefully I think we'll be the fastest. If you want the most up-to-date, on launch day, when we're sitting there streaming, we should have the lowest latency of anybody. So if you see, you'll see event, you'll see liftoff, I believe about 2 or 3 seconds faster than even SpaceX, because SpaceX is doing it in 4K. They are, I believe they're about, here we go.
To pause the clock T-minus 10 minutes to assess high-level winds. We'll update briefly with a new T0 time once we get new balloon data.
Crap, so they're not even going into a go, no-go poll.
From our launch director, Clay Walker, we are going to hold the clock at T-minus 10 minutes. We're currently evaluating those upper level winds and just make sure that the wind shear is okay with our stage 1 gimbal limits. We're going to coordinate with the range and make sure we have the proper data that is within acceptable limits before we have a new T0. Stand by.
As it is with rockets, patience is a virtue, my friends. I apologize, of course, all of us watching this are, probably like, oh, come on, just launch the thing. But obviously, scrubs are cheaper than booms, and, it is a waiting game. Rockets is definitely a waiting game. If you haven't watched a lot of rocket launches, this is nothing special. Although, first rocket launches, always will have more scrubs and more things go wrong. The limits that they place on a first launch are going to be more conservative, just because they want to get as far and have as successful as a launch as they can. So even things like, so what she's talking about when they're saying upper level winds, here's what they're talking about. I'm going to get my Falcon 9 model rocket out, the thing that you can get from everydayastronaut.com/shop. This thing here, okay, so the engine's gimbal, meaning they can tilt and steer the rocket. Similar to the Falcon 9, their rocket also has, let me do this, also has 9 engines. So as the rocket ascends into the atmosphere, what's going to happen is, there's ground winds, but all throughout the whole change in elevation, wind direction kind of changes, wind velocity changes all over the place, and the rocket needs to be able to steer for that. So it's going to use the 9 engines.
Updated launch time of 23:25 Eastern. That's 11:25 p.m. Eastern. We're going to wait for that final confirmation from the range, and then we'll pick up our T-clock accordingly at 23:15.
So 30 minutes from now, that's what we're looking at. Another back into the 30-minute range. But hey, it's not too bad. But yeah, so these engines, they actually can gimbal. They can steer on their, technically not Z, it's X and Y axis, is it? Because this is the X, Z and Y axis, axes. So they can steer and basically make a nice pattern like this. Maybe you've seen gimbal tests of engines. We're seeing a lot of gimbal tests right now of Raptor. They're switching out from hydraulic actuators to be able to steer the TVC to electronic actuators that are crazy fast. I mean, there's videos out there like NASA Spaceflight has a camera showing the gimbal test, and it's like brrr, it's just crazy. So they use that to steer it, kind of like the rudder of a ship, and that can steer the rocket. So they have to be able to, be within the range of acceptable limits of how much the rocket can actually steer. So they're not going to exceed, let's say, the big thing too with upper level winds is that the change in direction can be pretty dramatic. You can be, having, I'm making up numbers here, 100 kilometer winds going west, and then flying, even just 3 more kilometers up, it can be 100 kilometers going east, 100 kilometers an hour going east. So strong directional changes in the wind at altitude. And the problem is the rocket's flying through those altitudes at ridiculous speeds. So it goes from one extreme, 100 kilometers an hour, pushing it in one direction, to the other extreme in virtually in an instant. So the rocket has to be able to not only account for that with its steering, but it also has to make sure they're accounting for the forces that would imply on the rocket. If the rocket's suddenly switching directions and that wind force is changing directions on the rocket, you actually can exceed the structural limits of things like the interstage here. That bending force is going to be quite dramatic, and you can actually break a rocket in half. Also, just the general structural loads. Let's listen in.
For those that missed the previous broadcast, to do a refresher about the Terran 1 architecture. Let's go ahead and look at Terran 1 on a graphic up on the screen. So starting from the left-hand side of the vehicle, this is the bottom where we have the 9 Aeon 1 engines. In our previous broadcast, we talked about these engines getting printed using powder bed fusion or PBF technology. Each of these engines has a thrust capability of 23,000 pounds at sea level. This gives us a max total liftoff thrust of more than 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle, and we have thrust vector control actuators, or TVCAs, mounted on these engines in order to gimbal the vehicle during flight. We have completed more than 2,000 engine hot fires and over 10,900 seconds of runtime across Aeon 1 hot fire tests. The Aeon 1 engines are attached to the vehicle through the thrust structure. This is what takes the load from the thrust of the engines. And above the thrust structure is the stage with WAM printed tanks. This is our wire arc additive manufacturing in-house process. These tanks hold liquid oxygen on the top and liquid natural gas on the bottom. These tanks are pressurized during flight using an autogenous pressurization system. This works by running propellant through heat exchangers mounted on our engines, which convert the liquid propellant into a gaseous state, and this is piped into the top of the tanks to maintain our ullage pressure, or the required pressure for the tanks. Above the Stage 1 tanks is the WAM printed interstage, and this holds our stage separation mechanisms that separate Stage 2 from Stage 1 during flight. This is a pneumatic pusher system. And above the interstage is Stage 2, which has a single Aeon vacuum engine that is also printed with PBF. This engine has a thrust capability of more than 25,000 pounds in vacuum and has...
Announcement on countdown, this is the LD. We have coordinated a new UTC target time of 03:25:00. Clock will jump back to T-minus 16 minutes for go, no, go poll. And we'll begin count shortly thereafter.
So in about 10 minutes, we'll hear go, no, go poll.
Okay, there was that official confirmation of the new launch time of 23:25 Eastern. We are going to roll back the clock shortly to T-minus 16 minutes so we can go ahead and resume our go, no-go polling with our team of engineers and mission control, and we'll do that in alignment with 23:25.
So we got about 9 minutes from now.
And as we continue to wait, let's finish up on the Terran 1 architecture. As I mentioned, Stage 2 has WAM printed tanks just like Stage 1. And above Stage 2 is the WAM printed nose cone. So for future missions, this would be replaced with a fairing and also have a separation system. We don't have a customer payload as we discussed, but we did design Terran 1 for a payload capacity of 1,250 kilograms to low Earth orbit, or LEO, and 900 kilograms to Sun synchronous orbit, or SSO, for customer missions. All data from Terran 1 development will be fed into Terran R, and you can follow along our updates in the development, particularly for our Aeon R engine. We'll go ahead and take a moment to continue to look at Terran 1 out on the pad as we wait for updates from Mission Control.
Very cool. Okay, so again, we expect to hear that in about 15 minutes. 8 minutes from now. Yeah. Huge thank you from David Swenson. Holy crap. Everyone in chat, say thank you, David. That really, it just means the world to me. I mean, it's what allows us to, continue doing what we're doing. Obviously, spent a lot of time and money and effort on the latest video. Still have we have to get about double the views in order to make that video profitable. So we'll see. And that's not even any my time. That's just the time of our editor and our 3D animator Casper and Spencer. Yeah, it's gonna need about double the views in order to become a profitable video on that regard. So these tips like this and you guys all watching this live stream and the Patreon support and everything just really makes it so I can get that deep into these videos and really do such a deep dive and try my hardest on these productions to make them as high quality as possible. So thank you very much, David. That really genuinely just means a ton. David wants wants my thoughts on Virgin Orbit. It sounds like there are some... Okay, so Virgin Orbit, obviously, I'll get you guys up to speed if you're not familiar with Virgin Orbit. It's basically the 747 launching a rocket, it looks like a missile hanging out underneath its left wing. An orbital rocket company. It's different than Virgin Galactic. They kind of are... They were originally started by the same, company and everything, but they're both now their own companies. Virgin Orbit and Virgin Galactic. Virgin Galactic is the suborbital space tourism. Virgin Orbit is the orbital... small sat launch vehicle, kind of competing with Relativity here, competing with Firefly, Rocket Lab. They had their 4th launch recently, or 5th launch, and it failed. And it, kind of sent a shockwave through the company. They I think fully expected to be quite operational and not experiencing failures and not having much of a backlog and it sounds like, they were already a little bit worried about trying to reach full ramp up for profitability. So that being said, I have a lot of good friends that not a lot. I have a few good friends that work at Virgin Orbit. I've been there. It's been awesome. Really, I mean, the rocket is amazing. The idea is super cool. It's actually a video that I'm working on right now. Is kind of the why don't they just launch rockets from airplanes, air launch them and launch them from mountains and the equator and all these different scenarios. And it comes down to the idea of, in my opinion, one of the inherent flaws of this idea is you're flying the biggest, most expensive thing around the world when it's all going to be in space anyway. Like, it's all going to the same destination, whether you launch from Florida or the UK or, Dubai or whatever. It's all going to end up in the same orbit. So why are they flying the biggest part? Instead of flying the little tiny satellite on top to the launch pad and the rocket, they're flying the entire launch pad and the rocket and the launch pad to the customer. So it just makes it seems like it's backwards in that regard.
T0 time of 23:25 Eastern. The T clock is currently paused at T-minus 16 minutes. We're going to resume that T clock in about 5 minutes, where we're going to go straight into the go, no-go polls with mission control.
Can't wait. We'll be here for it. But I really hope, I don't know, it's a really tough situation right now. There's just a crazy amount of small sat launch vehicles right now, and the market is flooded with them. There's literally dozens of companies trying to launch to orbit for the first time, right now, basically. And so it's hard, and it is unfortunately sink or swim, and I would hate to see them go because I think it's such a cool concept. Watching it fly is amazing. It does not look great, though. I have a hard time really honestly imagining where it's going to go from here. So my thoughts are with everyone at Virgin Orbit. I really hope you guys can get back on your feet and prove everybody wrong. But right now it's not great. It's not great. All right, so let's get back to a couple more. From Tim Kittle, are you going back to Starbase? Of course. Yep, I will be there when it gets closer. When we get closer to launch, I will go down there. I've learned my lesson to mitigate my time there, because so many times I'll go down there a little too early and then sit around for weeks and weeks and weeks. I'm just not as productive there. I generally, like, the area is fine. I have some good friends down there, of course, that I like to hang out with. but it's just a different use of time. It's so remote. I feel so isolated there, and I just don't get a lot of work done. And I'd rather stay here in my zone in Iowa and just, you know, get work done and enjoy, you know, time with friends and family. I just feel like I'm a lot more productive here. And so I will be going down there just when we get closer. When I feel like we're within like 3 days is when I'm going to go down there. Because if we're within about 3 days, it means we're probably within like 6 days, you know. We know how scrubs happen and all that stuff. So I'm going to just try to minimize that. And of course, it's going to be scary because we are going to have a lot of people flying in for this one. Not only on our team, but just around the world. There's going to be so many people flying in. So I really am going to be trying to call that as late as possible. Don't want people going there, showing up, and then being like, oh, wait, actually, it's not flying for 3 more weeks. You know, that happens so often, especially with Starship, just because it is so developmental and it's such a brand new vehicle. Thank you to Ariadeta, PRDH. Greatly appreciate it. Have I started training? No, there's not been any training beginning yet for Dear Moon. But again, we're kind of just waiting on Starship at this point. We got to see Starship fly. The timing on that and how the success and the outcome of Starship's first orbital launch will put into play a lot of things in motion. Oh, awesome. Andy, I really, really hope that you catch this launch. Again, bright blue flame from Methalox would be really cool. Technically, it's actually liquid nitrogen, but Methalox nonetheless. Yeah. From the same person, Ariadita. Sorry if I'm Ariadita. I'm so sorry. I'm so sorry for that. Will they also prepare the 3D printer human capsule for their rockets, planning for docking to the ISS? Yeah, they I think have full plans to 3D print. The big thing they're dealing with, you know, obviously they can prove out if they can build a rocket, they can build anything. And the idea would be they would land these 3D printers on Mars and begin habitation and begin building cities completely autonomously on the surface of Mars before humans even get there. That's the key. That is the key. Ben says that this is all because no one has ascertained the status of the pointy end and the flaming end. Can't tell from this shot. We're going to have to wait for a little bit later on. Girlfriend Emily and I are huge fans and watch all your videos. Keep up the awesome work. That's so cool. I appreciate a couple watching my videos together. That means a lot. I don't think there's a ton of people out there that have a couple both interested deeply enough in the topics that we dive into to watch them together. So that means a lot. Thank you to both of you for saying hi. William Stewart became a member. Much, much appreciated. From Justin Stoddard. Thank you, Tim, for all the awesome videos. Excited to see you fly around the moon. Thank you so much. I really, 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 really appreciate that, Justin. What is going on? Thank you guys so much. Jeez, I've not been keeping up with you guys here. Thank you. Everyone say thank you to Justin. I can't wait to go around the moon.
We are less than 16 minutes away.
They're excited. They sound good. I love that. This is a good question from the Forbidden Juice in our Discord channel. Ooh.
Go poll for launch. Please provide concurrence to proceed in the launch countdown with go, no go. VC go. GC1 go. GC2 go. Ground go. AVI go. FTS go. RF go. GNC go. Flight software go. Thermal go. Prop 1 go. Prop 2 go. Fluids 1 go. Fluids 2 go. Loads is go. Rock ranges go. OSM RC go. Vehicle is go. CE is go. LC is go. All parties have reported go for launch countdown. Once the clock begins to roll, anyone can call for a hold at any time. A hold is called prior to T-minus 70 seconds. The T-clock will continue to roll until T-minus 70, at which point a hold will automatically be initiated. A hold is not possible after T-minus 70, and any hold call after that will result in a terminal count abort. Should a hold manual be necessary, the person calling for a hold or abort should state clearly on comms, hold, or abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and RC on primary net.
And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Let's take a moment to introduce you to our Mission Control team. Clay Walker, who you just heard, Launch Director. John Wiswall, Launch Conductor. James Harris, Chief Engineer. Elijah Escobedo, Vehicle Controls. Brian Batters and Zoe Dickard on Ground Control. Bill Stack, Ground. And Joy Mosdell, Range Coordinator. These are a few notable members also from leadership are supporting today's launch here at Launch Control, and this includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of CAPE Operations, Pat Svatek. These are among the many, many others who are making today's launch happen. Let's go ahead and take a moment to pause and listen in for any other updates from Mission Control.
Cool.
For our new viewers, let's give them a little bit more info about the systems that we're seeing on the pad once again. So the rocket rolls out of the hangar horizontally and is then lifted vertically by the transporter erector. That's the black vertical truss structure that you see behind the rocket there. The 4 large towers surrounding the pad make up our lightning protection system. They protect the vehicle from any direct lightning strikes. Inside of those, you'll see 4 small black posts around the pad called rainbirds. They're used for acoustic mitigation for the rocket and do so by covering the pad with water to dampen the reflected acoustics at liftoff. The small flame that you see there at the bottom right hand of your screen was once again the flare stack. No need to worry, this is perfectly intentional. It burns off flammable gases from propellant loading, venting operations, and priming of the engine igniters. It's a little harder to see, but the small slide-looking structure beneath the vehicle is our water-cooled flame diverter. It's used to mitigate the heat from lighting the engines, and it directs exhaust plumes away from the vehicle. You might also be able to see in this view 3 different levels under the rocket. So the largest and lowest level is the pad deck, and directly above it is the launch table. So this is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the transporter erector. So it transfers loads into the pad deck during hot fire tests and engine ramp up at launch. It also contains the release system or hold downs and the quick disconnect or QD carriages that provide propellant and other commodities to the vehicle when it's on the ground. I do once again want to give a big shout out to the ground crews out here for all of their hard work. They've helped us build and operate this launch infrastructure and supported vehicle integration and testing. And of course, they helped us prepare the vehicle again for this 3rd attempt. So thank you all so much for all of your incredible work.
Can I just point out, I love hearing the excitement in their voices. Since they reset the clock again, you can just tell, you can hear it in their voices that they're getting excited. It does feel like it's becoming a lot more imminent.
According to our latest weather balloon data, upper level winds are currently go. So the T-clock is going to continue to roll.
Minutes, countdown sequence has started.
There you go. We are just 10 minutes away from this historic launch.
Like I said, you can hear it in their voices. They are getting excited. That's the stuff that I love. I love that human connection. I love feeling connected to these people and their work and the people involved in building these rockets and getting humanity deeper into space and learning more and more about our place amongst the stars and just making new discoveries and pushing humanity forward. Yeah, I just love that. That's actually like that's the whole reason.
Minus 9 minutes and 20 seconds. Now, in the next few minutes until launch, you'll hear callouts from our engineers and mission control as we go through the final procedural steps before liftoff. We'll be pressing the tanks, priming the igniters, doing the final engine checkouts, retracting the strong back, and then getting that final go for launch. We're currently proceeding with the launch time of 11:25 Eastern. That is 23:25 Eastern. Let's continue to listen in.
I love it, guys. This makes me happy. You know, and this is the whole point of Everyday Astronaut. This is the whole reason why I started this, was just to help share my excitement for this stuff. And my excitement gets fueled by their excitement, by the engineers, the scientists working on these projects, on these rockets, on these programs. It all comes full circle. The more they get excited, the more they do cool things, and I get to learn more stuff, and hopefully get you guys excited along with me too. So thank you for tuning in with me here tonight. I know for a lot of people, especially if you're in Europe, say hello. If you're from Europe, you are staying up very late for this little tidbit of history. Hopefully tonight we will see the world's first successful orbital launch attempt of a methane rocket. As a matter of fact, they could also potentially be the first rocket. If they get to orbit on their first attempt, they would probably be, by most definitions, the first rocket to make it to orbit on their first attempt. They're now pressing with autonomous pressurization. I just heard that in the callouts.
Views, we are launching at night today, but in terms of our vehicle, it doesn't make a difference if we're launching during the day or at night. The systems operate the same. You are able to see those white clouds a little bit more clearly now. So that big white cloud you're seeing come out of the strong back is due to strong back chill operations. So we're chilling all of the ground equipment to try to get our LOX as cold as possible for stage 2. Smaller white clouds that you saw earlier coming out of the vehicle at different levels are due to the venting of the chilled gas from the rocket. And that venting into the humid Florida air out here is what causes the gas to condense into vapor and look like clouds. You can also see the frost on the rocket and what looks to be small white pieces falling off. That's all just ice, and it's because of the chilled propellant inside. It's so cold that you'll see ice falling off the vehicle.
Liquid oxygen, liquid methane. Very, very, very cold.
Stage 2 igniter configured for priming.
Minus 183 degrees Celsius.
Well, let's walk through the launch timeline now that we're getting closer.
Yeah, at T-minus 70 seconds, the vehicle will go into terminal count, and this is when the vehicle's internal flight computer takes control of the countdown. We'll then go into final flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6 seconds, we're going to see that blue fire and have ignition of those 9 beautiful 3D printed Aeon 1 engines. And then at T0, we will have liftoff and Terran 1 will fly. Shortly after, at T plus 2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly. And then at T plus 12 seconds, we'll begin our pitch over program. So we'll go downrange in an easterly direction over the Atlantic Ocean. And then at T plus 80 seconds is that very important milestone of max Q, where the structural loads on the vehicle are the highest.
At approximately T plus 160 seconds, we'll get to main engine cutoff, or MECO, where the stage 1 engines will shut off. This is followed shortly by stage separation, and the Aeon vacuum will ignite. Aeon vacuum engine will ignite on the second stage. Second stage will burn for a little under 5 minutes. Then at approximately 463 seconds, we'll get to second engine cutoff, or SECO. We'll go ahead and tune back in to mission control.
I should make a quick little note here. Amazing. Thank you so much for the incredibly generous donations. I will try my hardest to get to all these questions after launch. So I do want to listen in here at the end, and we're going to really pay attention to what's going on. But, I mean, a quick shout out to Jack King, another $100 donation. Thank you so much, Jack. I will get back to you in a second. I mean, just thank you. Everyone say thank you to Jack along with me. I don't even know what to say. So thank you, sincerely. Let's listen in here.
Stage 2 igniter, the flight target.
We're now priming those igniters with gaseous oxygen and gaseous hydrogen. In just about 30 seconds, we're going to be looking for the transporter erector cradle to disengage.
There goes the claw.
Stage 2 is on internal power. EE cradle disengaged.
All right, now those cradle arms are going to slowly release stage 2 so the strong back can retract. You can see the arms opening up there.
Love hearing a rocket come to life like this. Gimbal check.
Stage 1 TVC checkouts running.
And now you'll be able to see the stage 1 engines gimbaling or tilting as you see while we're completing those final thrust vector control health checks.
I love that.
Stage 1 is on internal power.
It's getting chilly down there. Isn't it unbelievable how cold the rocket in this whole area would be right now if you were close enough to be able to feel that? It'd just be freezing. So much.
The strong back will be retracting shortly here.
So yeah, I'll see the thing on the right, the tower on the right, will recline a little bit away from
Strong
the
back is
rocket.
retracting.
There you go. We're retracting that black truss structure to prepare for
Stage 2 TVC checkup.
umbilical separation now that both stages are on internal power. And now we're doing those final thrust vector control health checks on the upper stage.
There it goes.
Starting final review of launch commit criteria.
Wow, we are very closely approaching T-minus 1 minute. I just want to remind all of us here that what you're looking at on your screen is 85% 3D printed, and it is about to fly.
Yeah, not just fly. Go to orbit, baby. This thing is ready to go.
Next up, our range coordinator will ask the range for their final status.
Please be range green. Please, we need the range to be green.
Rock, report range status.
Range green.
Yes.
That was confirmation. The range is green for launch.
And they made it past T-minus 70. Okay. It is into the final sequence here.
Propellant closing out.
Flight computer configured for launch.
They're doing it, guys.
Under 1 minute.
Come on, Relativity. You can do this.
LD, are you go for launch? LD, go for launch.
There's that final go for launch. We are just over 30 seconds away until the maiden launch of this vehicle. Good luck, Terran 1, and have fun. Here we go.
Have fun.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Yes!
Terran 1 has cleared the tower.
Switchover maneuver starting. Launch pad facing.
Look at that blue fire!
Yes! Wow.
You can hear me over the cheering. The vehicle is now headed downrange in an easterly direction over the Atlantic Ocean. Our next ascent milestone is max Q, around 80 seconds.
That's the point where we're going to really test out that 3D printed
Terran
structure.
1 is supersonic.
Good telemetry switch over at the ground station.
Here's max Q.
Max Q.
We are on our way to making a new history. Terran came ready to play today. You just heard that call out indicating Terran 1 just made it through. Max Q. We just completed a major step in proving to the world that 3D printed rockets are structurally viable.
Amazing. Absolutely amazing. Look at that. I love that blue flame. Methane is going to be so fun. So many rockets. Methane is so in right now. It's so hot
Up
right
next,
now.
we'll be looking for a call out that stage 1 performance is nominal.
It's cruising. About a fifth of the way through orbital velocity. Coming up on a fourth of the way. The first stage does a lot of the heavy lifting, but it's the upper stage that actually does the majority of the velocity change. Remember, their video feeds here might break up a little bit. There's Miko. They're going through stage separation right now. And hopefully, second stage ignition. There it is.
As you can see, we were waiting for Miko and upper stage ignition. This means that we had a main engine cutoff for stage 1, and directly following that, we had second stage ignition, which you can see the Aeon
velocity's
vacuum
going
engine
down.
in that beautiful view in the night sky. Reminder,
cut
there
off.
is no fairing for this maiden launch as we don't
Hey.
have a customer payload, but we
Amazing.
do instead have a memento of the first ever circular test print.
It's done. Did not reach orbit, but huge milestone. Getting through stage separation and second engine ignition, massive. That's huge. I'm not sure what happened. The gimbal's still trying to counteract it, but it is still coasting upwards, but it definitely appears
We are currently standing by for an update on what's happening with the stage 2 engine.
Yep. This is okay, though. They were so excited to get through maximum aerodynamic pressure. That was a huge milestone. Again, this is a demonstration mission. It's okay to fail on your first launch attempt. They are going to be celebrating tonight. This is a good thing. Yes, they didn't likely now make it to orbit. But getting through stage separation, proving out your stage separation, doing initial ignition of your second stage, huge milestones. So they are in, I mean, I don't even know how many companies have ever done that on their first launch attempt. That's huge. I don't think any that I know of even got through the first stage burn. Whew, man. Yeah, they proved the most important part of their entire concept, which was getting through max Q. So huge, huge props already. All the way through first stage. First stage has been validated.
Announcement on countdown. This is the LD. There has been a T plus anomaly with stage 2. LC, please begin anomaly procedure section 25. Copy.
Thank you, Relativity, for being so open with us about this. This is amazing to have this kind of coverage and this access to the information. We're watching and learning in real time. Just really is amazing for us spaceflight fans to be able to be tuned in like this. So thank you, thank you, thank you for watching along with us.
As you heard from our launch director, we did have an anomaly with Stage 2 during flight. But maiden launches are always exciting, and today's flight was no exception. Although we didn't reach orbit, we significantly exceeded our key objectives for this first launch, and that objective was to gather data at max Q, one of the most demanding phases of flight, and achieve stage separation. Today's flight data will be invaluable to our team as we look to further improve our rockets, including Terran R.
Our team will now carefully analyze this data to determine what led to this outcome. So stay tuned to @Relativity Space on Twitter and relativityspace.com for additional updates in the days and weeks ahead.
I want to thank the entire Relativity team for all of their hard work in getting us to this point. No one's ever attempted to launch a 3D printed rocket into orbit, and while we didn't make it all the way today, we gathered enough data to show that flying 3D printed rockets is possible.
As Arwo mentioned, we will apply the lessons learned today in our future vehicle, Terran R. What we are doing has never been done before, but it is undoubtedly a worthwhile endeavor that will transform the aerospace industry forever. And with that, we will conclude our coverage for tonight. I am Rachelle Aniceto. It has been an honor.
And I'm Arwa Tizani Kelly. Thank you, and see you next time.
Honestly, amazing. Absolutely amazing. All right, everybody. It's your turn in the chats to give a little applause for Relativity. That was so great. I'm really, like, that's a big deal. They made it through the biggest milestones. I'm trying to find out where did this go now. Yeah, I mean, that is just absolutely massive. I can't say enough. I can't think off the top of my head another rocket company that has made it all the way through the entire first stage burn up to stage separation on the first launch attempt, besides Pegasus, which, you know, I don't know if we want to call that a private company, and that was a solid rocket booster, so a little easier. Pretty amazing. Absolutely amazing. Man, that was fun. I'm happy for that one. I am glad that one is in the books now. So huge congrats. So we're going to answer a few more questions, and I'm going to get out of here. I streamed for 6 hours earlier because I couldn't stop. And we've already been here for a couple hours already too. So let's tidy up here, answer a few more questions. Before we do that, don't forget, if you guys want, you can get our incredible 3D, not 3D printed actually. These are mold, injection mold. Falcon 9 model rockets. Again, these are entirely or mostly metal. I don't want to say entirely metal because they aren't entirely metal, but mostly metal. And you know, we have things like collapsible landing legs, and this thing can stand on its own. It's just an incredible. I don't think you're going to find a higher quality rocket model than this. This is 1/100 scale. It's the first of our 1/100 scale rockets. Again, you can hear it's made out of metal. It's heavy. It's like really heavy, which is part of the reason the shipping's so expensive to Europe. Sorry, Europe. Maybe the next run we'll do in like injection mold plastic or something. But this is beefy. You can clobber somebody on the head if they break into your house. This could be a home defense tool. But you can get these at everydayastronaut.com/shop. Pulling out the little grid fins here. Just absolutely so proud of this rocket. It's been over 2 years in the making. We finally have a few more back in stock. We're trying to keep them in stock for you guys. If you want to help support what I do, everydayastronaut.com/shop. You can see our incredible Falcon 9. They come in this awesome box with a really cool instruction manual too. I mean, this is like I said, you won't. Factually speaking, I think just objectively, I don't think you're going to find a higher quality, more detailed model rocket than this. Period. And the packaging and all of the stuff just makes it. We're trying really hard to make it an incredible product. So if you want to support the work I do, the most fun way probably is to go over to everydayastronaut.com/shop, pick out something for yourself. Much appreciated to all of you for watching. The tips and super chats have just been incredible, speechless. I love you guys. This has been so fun. This has been such a fun one to cover. So let's get back to answering a few more questions before I get out of here. We did have one that we were in the middle of answering, and then it got interrupted. So This is from the Forbidden Juice in our Discord channel. If you're a Patreon member, you can gain access to our incredible community on Discord. This is from the Forbidden Juice. Is there a certain altitude at which rocket exhaust no longer contributes to global warming effects due to being in space versus our atmosphere? That was a really hard, it's actually not a very well understood topic. And then I see that there's a follow-up question, and I'll include this about mostly wondering if having a hydrogen first stage without SRBs and a Keralox upper stage would actually be a fairly clean rocket CO2-wise. So the big thing, actually, water vapor is not a good thing to have in the upper atmosphere. It does actually trap a lot of heat. As far as greenhouse gases are concerned, water vapor is one you would like to avoid. So believe it or not, hydrolox and hydrogen engines can produce that. Methane rockets do too, and they also produce CO2. But overall, a Keralox engine is, what was it? 10 times worse in the upper atmosphere than a purely hydrogen rocket, just from an overall greenhouse gas effect. Something like that. There's a little bit more that I learned afterwards, but a lot of it's still being studied, actually. A lot of it's still being studied. And I did have a couple things wrong, which is why I would love if YouTube had like a way to academically update videos so you could insert corrections to the work being done so as not to be ever misleading and be a continually good source of information. All right, this is a good fun question from Mans on Mars. What song will I be playing in my head or in headphones as you go around the dark side of the moon? I don't know what a song exactly. A song that I would like to play for sure on my journey. There's a song by one of my favorite bands called Foals, and they have a song called is it just On the Luna? And it's cool. It's a song in like 9/4, kind of a bar of 4, bar of 5 for the chorus. You don't even notice; they just play straight through it. You don't even notice that's in totally odd time. It's a super cool song. It has a couple lines that just are like, yeah, this is cool for spaceflight. I don't think it's meant to be cool for spaceflight, but yeah, it's just fun. So that's what I'll probably be listening to. Wheelbarrow, holy crap, thank you so much. Yes, I will be broadcasting from Starbase again very soon. Hopefully, like I said, in 4 to 6 months is my feeling. Thank you so much. Really, really, really appreciate it. Adrian, thank you so much. Thank you, Tim, for all you do. To see this channel go from cheesy, funny videos with a guy in a spacesuit to someone who is living what many would only dream of. I'm jealous and grateful to watch and share the experience. Well, thank you so much. For me, again, that's exactly what it's all about, is just simply trying to share the incredible experiences that I'm able to witness, see, experience firsthand. The people that I get to talk to, it's just incredible. It is absolutely a dream job. I am fully aware of how incredibly fortunate I am, and I feel it's my duty to share it as best as I can. And that's the whole reason I'm trying to actually kind of dumb down on doing live streams in person, just because I want to do it justice and I want to share that experience with people. But it is becoming to the point where, it's pretty easy to see a rocket launch these days, and it used to be a lot harder. But I am trying to share that, especially rocket launches like Starbase and Starship are going to be very hard for someone to go and see. It's a very remote location. Florida's still very far away from a lot of people, but I feel like there's a bit of an obligation there. I really want to watch, these big historic milestones happen and share it with you guys. But I think in the future, after Starship becomes routine, I'll probably wind down on doing live, at least in-person launches, and just kind of do them like this, just casually, out of the comfort of my own home, basically, and not really worry too much about it. To both of these questions about the New Glenn model and Firefly Alpha model, both of them came from the manufacturers themselves. Blue Origin sent me the New Glenn and the New Shepard. Firefly sent me the Alpha rocket. My goal, again, with rockets is I'm going to make a 1/100 scale collection so that you can see how tall Firefly's Alpha is compared to the Electron. It's actually a lot bigger than the Electron, but here it doesn't look like it. And see how big New Shepard is compared to a Delta IV Heavy. That's what I just can't wait to do. And we are in the middle of trying to figure out the next thing. So, all right, this is from Dylan Saxman. I love your channel and you really helped me connect with my inner kid and my fascination of space. It really means a lot to have a getaway through science after a long day of work. I couldn't agree with you more. Thank you so much, Dylan. Really, really appreciate that generous donation. Thank you so much, Dan C. Very much appreciate it too. And Dylan for becoming a member. Very, very appreciate that. And Bree, hopefully you saw the color. It was the bluish, a little hint of green in the blue, but pretty darn blue color in the exhaust. I love seeing that. That's going to be so common. Don't forget, we have Relativity using Methalox. We have we have Stoke. We have ULA's Vulcan going to be using methane. We have, of course, Starship using methane. Methane is the new sweetheart in the spaceflight industry, the new common propellant. So we're gonna see a lot of it. Get used to it. This is from Space Geek. We appreciate what you do, Tim. Many times on launch day, we stream your videos at Rocket Lab. I would like to see you do a short spotlight interview of people in the industry to promote new space and STEM. I'll be the first. Space Geek, I would love that. Thank you for the work you do. I love that too, and I was really excited when Firefly offered me the opportunity to interview some people, employees. It's actually really hard to do at a lot of companies. Lots of times, just media relations wise, they kind of want to, at SpaceX, I would love to interview Gwen Shotwell, Hans Königsmann, former employees like Tom Mueller. But so far, it is hard to do that. And so I would love to be able to get in there and talk to more and more people at companies and learn about the work that they do, because there's a lot of really talented people just doing incredible work that we can only even imagine. It seems like there aren't many good re-entry videos from inside the vehicle. It would be amazing if you can get video from your Dear Moon mission. I would love that too. That would be incredible. The crazy thing to think about is I don't know where we're going to be sitting. I don't know what the inside of Starship's going to look like. But there's a chance that we could be up in the part that has the windows on our backs and looking up or something, looking out the window, and we'd see looking up the window on reentry just the plasma. I don't know. I hope that would be insane. That'd be so fun. Wow, in Germany up, impressive. Thank you, Keeper of Rapture. I'm just trying to fly through a couple of these. This is No Way, Astrolord. Watch from 36,000 feet on the way back to Houston. Amazing time to be alive. Incredible that you had good enough service to be able to watch a live stream. Just amazing. Terry's Workbench, 23 months, a membership. Thank you so much. Those engines honked like Raptors when they fired up. Did they? I might have missed the honk. I feel like the honk's more common on shutdown on a Raptor, and I still don't know what exactly causes that. Ted Space, thanks for bringing it to us. Saying hi from Omaha. Well, hello, neighbor. Thank you so much for saying hi. Much appreciated. Chip A, thank you for becoming a member. From Dash Riptide, after seeing people laugh at Elon for wanting to do what he's doing, seeing a giant 3D printed blowtorch fly now after a giant beer can, nothing is impossible. You are right. I do really like the concept of 3D printing. It shows that they could just really iterate on this idea very, very quickly. Where does the second stage go if it didn't get into orbit? It'll follow its ballistic trajectory and fall, 400 or 500, 600 kilometers or 400-ish miles or so downrange. So it'll basically just make an arc. It only is going to go a little bit further than the first stage. The first stage, normally just kind of falls and lands, and for SpaceX, they land, we'll just say 400 kilometers downrange, 260 miles. And is that right? 240 miles. And that's just because it follows the ballistic trajectory. And then it normally lets go of the second stage. The second stage speeds up enough to just stay in orbit, to get into orbit. And that's my guess is the first stage, the second stage is going to be really close to the first stage. So it just is going to fall back into the ocean. Ian, thank you for becoming a member. Tech Controls. The methane looks so cool. Can you imagine 33 engines going up? Thanks for the stream. I can imagine it, and it's going to be incredible. When Starship launches, you're not going to want to miss that. It's going to shake everything around it. It's going to be bright. It's going to be loud. It's going to be mind-boggling. It's going to be absolutely incredible. Jeff, thank you for becoming a member. Much appreciated. A lot of new members tonight. I can't wait for the next stream. It's going to be so fun. The next video I'm working on is actually explaining orbits, suborbit versus orbit, a really big deep dive into just getting into orbit, what it takes versus, just a suborbital ride. We're going to actually dive into the proper rocket equation. I'm going to teach you things like dry mass, wet mass, how that all works out with your mass flow rates and everything, specific impulse, and how that all works into the rocket equation. We're going to build a couple rockets using the rocket equation, see what it takes to go from suborbital up to orbital, using kind of the same parts. It's going to be really cool. I really, yeah, I'm really excited for it. And then that will go into answering questions like, why don't you do air launching, catapult launching, mountain launching, equator launching, and we'll all apply that through kind of the lens of that video, of the video that comes before it. Thank you for the membership, LM. Much appreciated. I hope that would be fun. Flying Me to the Moon would actually make sense. Schizo Jed, 44 months of membership. Do you have a small experiment or something cool you plan on taking up with you? Perhaps some Mentos and a Coke? That would be hilarious. Can you imagine doing that in space? It'd make a huge mess, but it'd be super fun. I've got some really cool video ideas and kind of experiments that I'm going to be doing. I don't want to talk about it too much because it's my ideas. You'll see. It's going to be some really fun things. Let's see. Mark says, is the second stage engine the same as the first except being a vacuum? Yeah, it is the same exact engine with a different nozzle extension on it. So it has a little bit better vacuum performance. Yep. Similar to what we see with Falcon 9 again. Sorry to keep pulling this up. 9 Merlin engines, vacuum engine, still the same like pumping and combustion chamber as the 9 down here, but a bigger nozzle on it makes it optimized for the vacuum of space. Oh, that's cool. Colin says, living in Orlando area, it looked a lot like what you'd envision Star Wars rockets with a big bright blue star in the sky. That's super cool. I wonder, it probably is brighter looking than hydrogen, a pure hydrogen engine, because there is also some carbon in it, some CO2. And I wonder if that just makes it burn a little bit brighter, but still bluish. Wildly Coyote just shows how hard it is to start an engine in space. Thanks for your video on how complex it is. Yeah, I didn't mean for that video to be a primer there, but yeah, starting a rocket engine in space. I want to rewatch the launch actually and see what exactly went wrong, because I'm gonna look through it because it looked like the engine lit up and was running for a brief moment. So I'll be very curious as to what they figure out and what the anomaly report shows. So, all right, my friends, it is time for me to. Oh, did I say 4 to 6 months for Starship? Sorry, I meant 4 to 6 weeks. When I said 4 to 6, at some point I must have said 4 to 6 months. I mean 4 to 6 weeks. All right, that's gonna do it for me, my friends. Yeah, I missed you guys. I had a lot of fun streaming tonight. It was really fun watching a really exciting rocket company do their thing. It's just been a lot of fun for me. So I hope it was fun for you guys too. Again, huge congratulations to Relativity on the impressive milestones. So fun to watch. I can't wait to see more. Hopefully, you know, I had mentioned Tim Ellis, the CEO, and I've communicated a few times. We were trying to get something done before launch a couple months ago. We kind of decided to wait until after launch, but hopefully I'll be able to do an interview with him and maybe some of their team members and see some of their new engines, see their factory. Just exciting stuff. Yeah, I'm really excited. Hope you guys are too. Hope you guys have a great rest of your week. Next launch you'll likely see from me that I know of might be Starship. Starship might be the next launch that I stream. We'll see. I might squeeze another one in here or there. And probably do another Patreon stream in the meantime. Patreon/YouTube member. So thank you for all of you that tuned in. Really means the world to me. Yeah. Be sure and watch, if you haven't seen it already, be sure and watch my How to Start a Rocket Engine video. Hopefully you'll learn a little bit more about what we just watched today and even maybe gain some insight on what happened in second stage ignition. So that's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody.